We are told that there was a robotic challenge, and that challenge was to have robots competing in terms of the speeds at which they could move. You see, in this question, you have been told that the speed time graph of a particular robot in that robotic challenge was recorded. And if you look at this graph, we are told the figure below is not drawn to scale. So it just seems to be a sketch that represented the speed of that robot in that robotic challenge with change in time. So you're told that the y-axis represents the speed or the velocity in meters per second, and the x-axis represents the time the robot took while moving at different speeds in seconds. So begin from 0 up to 60. Then the velocity that the robot began with was 4. If you look at that on your y-axis, and that was the velocity, now 4 meters per second, and it accelerated and then attained a maximum velocity m. It maintained that constant velocity m to a particular point in how many seconds? From 15 seconds to 45 seconds. Then it began decelerating. So descriptively, I can be able to say that the maximum velocity reached by this robot was m meters per second. The velocity that the robot began with, or u, was 4 meters per second, but our final velocity v was m meters per second. In the first 15 seconds, the robot accelerated to a maximum velocity v, or m meters per second. After attaining that maximum velocity, from 15 seconds to 45 seconds, the robot maintained a constant velocity, of which it was actually the maximum velocity. Then, in the last 15 seconds, the robot decelerated. Now, you are told to actually first get the value of m. Look at this question. If the distance covered by the robot in the first 15 seconds was 180 meters, calculate the value of m. I know very well that if you have to actually look at a velocity time graph, then you want to really get the distance that a particular body covers, or even a particle, you are just supposed to get the area under the graph, and that can give you the distance that the body covers when moving at that velocity within that particular time given on the x-axis of your velocity time graph. So, distance covered is equivalent to the area under the graph. So how? If I talk about this as my A, this as my B, and this as my C, I'm going to have this. The area under A. Why? Because I'm told in the first 15 seconds, the robot covered 180 meters. So the area under A, we shall actually just say this must be a trapezium. So area under A, which is a trapezium. So this is a trapezium, this is a trapezium. Look at that. So we are told here the starting velocity was 4, but we have what we call the maximum velocity that we really don't know, which is represented by m. So that means from here up to here is 4. And we are told that the time taken is from 0 to 15. So area under trapezium is going to be A is equals to a half into A plus B times height. So I just say a half into, what is my A? I can take this to be my A and this to be my B. And this is the time taken. Look at that. So my A is 4 plus my B is M, then multiply by the height. That translates into the distance covered within a particular time. That gives us now 15 seconds. And that should give us the total distance, which is actually 180 meters. So we can open the brackets. We are going to have 2 plus, so that is a half times 4, that gives us 2. Then a half times m is a half m. Okay, then we are going to multiply this by 15, so that we are going to have 180. If we further open the brackets, we are going to have 2 times 15, that gives us 30, plus half times 15, that gives us 7.5 m, that translates into 180. We shall take that on this side. So 7.5 m is equals to 180 minus 30. So 7.5 m is equals to 150 divided by 7.5 divided by 7.5. So let's see. We're going to have 150 divided by 7. That gives us 20. Yeah. So our m, or the maximum velocity attained by this robot, is 20 meters per second. Now, you have been told to describe the movement of the robot between the 15th and the 45th seconds. Between the 15th and the 45th seconds. You know, from this point to this point, that robot maintained a velocity of 20 meters per second. So you can say, between the two times, the robot maintained the maximum velocity attained. Velocity attained, which was 20 meters per second for 30 seconds. So it maintained a maximum velocity. That means it moved at a constant velocity. It never changed its velocity. It maintained a constant velocity of 20 meters per second. So the robot maintained the maximum velocity attained, that is 20 meters per second for 30 seconds. Or you can say the robot moved at a constant velocity of 20 meters per second.